back. Part of the conversation we had previously, when we were talking about quality service for applications, you talked about proportional scheduling. Tell us a bit more about that.
Okay, so in a traditional storage environment, we've grown up with basically the storage array handles an I/O as it sees it. So we talk about first in, first out queuing, or FIFO as the common term is. In a virtual machine environment, we've got this randomization of I/O. 100% random I/O comes from the hypervisor layer itself. So what we want to be able to do is have a very good understanding of all of those I/Os. And I mentioned before about instilling fairness and not having bandwidth-hungry virtual machines starving out latency-sensitive virtual machines, which obviously gives you the ability to mix and match virtual desktops and server VMs on a common data store, which has been difficult to do in the past. What proportional scheduling actually does, and I'll use an analogy to explain this point. Let's say, for example, you're out on the road today and you're feeling hungry, you decide you're going to go to McDonald's to buy a burger and you're going to go through the drive-through.
Okay.
So the great news is on this particular day, you've arrived at the drive-through and there's only one car in front of you, which is pretty unusual.
Very true.
So the great news is you're starving hungry, you're going to get your burger pretty quickly because you've only got one guy in front of you. And then all of a sudden the guy in front of you orders 50 Happy Meals. You're now queued up behind Mr. Happy Meal. The traditional storage approach would be to service all of the IOs for Mr. Happy Meal before getting to you. What Tintri does though with proportional scheduling is it says, okay, I can see all these IOs. I'm going to take you out of the queue, service your IO, your one IO, and I'm going to go back to servicing Mr. Happy Meal. So Mr. Happy Meal didn't notice this, you didn't notice this, so everybody gets great service.
Sounds good.